Hi, everyone. This is Mrs. Poland for the math team practice session number 6. I want to thank the captains for running a great practice. I know it was short and people had to leave, so I decided to make a video of some of the problems that may help in our last competition this upcoming Tuesday. If you were unable to attend today's practice, if you come by the room, I can give you room at 4. I can give you a hard copy of the practice sheet. Okay, so number 32. When x squared plus ax plus b is divided by x plus b, the quotient is x plus b, and the remainder is negative 20. If a and b are real numbers, compute the sum of all possible values of a. So, how are we going to do this? Probably the easiest approach is to use the formula for a polynomial based on its quotient, divisor, and remainder. So this is one of the big concepts that's in Algebra 2. So the polynomial is equal to the quotient times the divisor plus the remainder. So we know that the polynomial is x squared plus ax plus b. It's defined right here. We know that the divisor is x plus b. And we know that the quotient is also x plus b. So we're just going to fill that in here. And we're subtracting out the remainder. So what am I going to do next? Well, I'm kind of going with the flow, and I figure I'm going to multiply these out and see where it takes me. So x times x is x squared, x times b is bx, x times b is bx, plus b times b is b squared. And now I'm just going to bring down the 20, and I'm going to bring down the left-hand side of the equation. Remember, our goal is to find a, but we may need to find b first. I notice I can subtract x squared from both sides of the equation, and what that leaves me with is terms that have x's in them, and then terms without the variable. And so what I'm going to do is I'm going to make two separate equations, one for the terms with the x, and the other one with the terms that don't have the x. So I know that ax is equal to bx plus bx, and I know that b is equal to b squared minus 20. I combine like terms on the right-hand side here, and I get 2bx is equal to a. And as far as the coefficients are concerned, I know that a has to equal twice whatever b's value. So let's keep that in mind and hold that on our side. Now, for the constants, the terms without the x, I know that b is equal to b squared minus 20. And I say b squared, that's a quadratic equation. What if I were to put this equation into standard quadratic form by subtracting b from both sides of the equation? Well, that's certainly an equation I can factor. So two factors that multiply out to negative 20 and add to negative b are negative 5 and positive 4. So I know one value of b is 5, and the other value of b is negative 4. Well, how does that help me? Well, now, since a is twice b, one value of a is 10, and the other value of a is 2 times negative 4, or negative 8. Our goal in this problem is to find the sum of all possible values of a. Remember, your answers are single integer values. So therefore, all I need to do is add 10 and negative 8 together, and I get the correct answer of, the sum of a as 2. Okay. Problem number 3. So this summation symbol you may have seen in Algebra 1, but certainly this is something that we do in Unit 12 in Algebra 2. This E thing is actually a capital sigma, and it means sum. And what it does is it tells you to input values into K, starting with 1, and you keep on incrementing that value of K up by 1, and then you end with the last input of that top number, N. So this becomes 1, because I'm putting it in for K, increment K by 1. You get 2, increment K by 1, 3, and you keep on going until the last number you substitute in is N. And that sum has to equal to 2,850. Okay, so now what do I do? Because my goal is to find N. Well, this is an arithmetic series, which you all learned in Algebra 1. And there actually is a formula that gives you the values to sum the sequence. And that formula is N times N plus 1 divided by 2. Unfortunately, they don't give you this on any formula sheet, and you need this for Algebra 1 as well as Algebra 2. And for those of you who are taking BC Calculus, you're going to need it for BC Calculus in one of the final units. So this is an arithmetic series, and it's the sum of the arithmetic series. So how does that help us? Well, I know 1 plus 2 plus 3 plus ... n has to sum to n times n plus 1 over 2, and that's equal to 2,850. Now what? Well, I can cross multiply or multiply both sides by 2, and I get n times n plus 1, and 2 times 2,850 is 5,700. Now what? Well, it looks like it can distribute, so I'm kind of going with the flow, and I get n squared plus n is equal to 5,700. I subtract 5,700 from both sides of the equation, and now I'm going to factor. And you're going to say, this is Poland. That's a crazy high number to factor. Well, on this competition, you can use a calculator. So we're going to go into our calculator, and the way I'm going to show it, and there are other ways, and I'm sure the captains would be happy to show you how to do it, but I, as an Algebra 2 teacher, I'm kind of a little nervous about showing that. I don't want to give all the secrets away. And what I'm going to do, but this one I definitely show all students, I'm going to go into the graphing utility of the calculator, and I'm going to hit tab. Uh-oh, it's going crazy on me. Hold on. I'm going to hit tab, and I'm going to take that negative 5,700, and I'm going to divide it by x. Hit enter. I'm going to hit Control T, and that gives me a listing of all the factors. Now remember, I want a difference of -1, so I keep on scrolling, getting a little nervous here. I don't see it yet, but I keep on going, and that's like some things you have to do. So next week, though again, the captains can show you a couple of tricks that I'm not comfortable showing. And lo and behold, 75 and -6 add to -1, and those are the factors. So n minus 76, n plus 75. So one value of n is positive 76, and the other value of n is negative 75. We're going to reject the negative 75 because you need to have a positive value, and the final answer to this problem is 76. Okay, next problem. Okay, number 40. This is an Algebra 2 topic. You also see it in pre-calculus as well as calculus. Some of you may not have seen it in Algebra 2 yet, or if you're taking geometry, you may not have seen it. And basically, there's something called the power rule in logarithms. So we're given this logs, and we're told that the sum of all these strange log functions is equal to 156. And we're also told the base b is equal to 10 over 1 over n. And they want you to find n. So we're going to use something called the power rule to help us out, which I'm actually showing tomorrow in my classes. And what the power rule says is that if you have a logarithmic expression with x as our argument or an input raised to, and that argument or x value is raised to the n, that power of n, this is the same thing as n log base b of x. And this is known as the power rule. Okay, so how do we do this from here? So I'm going to apply the power rule to each one of these items. And remember, dot, 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 you're adding terms consecutively until you hit log base b 10 raised to the 10. So this becomes 3 log base b of 10 plus 4 log base b of 10 plus 5 log base b of 10 plus dot, 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 plus 10 log base b of 10, and that has to add to 156. Now what? Well, I noticed something. I noticed that there's a common value of log base b in the left-hand side. So what do? This is a traditional mathematics tactic. We factor it out as the GCF. We do that a lot in math, in higher level math. So I'm factoring it out, and I'm left with 3 plus 4 plus 5 plus dot, 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 plus 10 is equal to 156. Now what? Well, I'm no fool. I can just type that into the calculator. So I can type in 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10. And if you do that, you get a sum of 52, and that's equal to 156. It's starting to look pretty nice here. So then I say, well, now what? I need to find like n, and I know it has something to do with b. I better isolate my log function. Again, that's something traditionally we do. And if you're in my class, we're going to actually do that tomorrow. So this is log base b of 10 is equal to 3. So now what? A log is just the exponent. And so in order to solve a logarithmic equation, even the mini one like that, we're going to put it in exponential form. Remember, the base is in the basement. The exponent is by itself, and this is our argument or our final result. So we want to put it in base raised to the exponent is equal to n. So b raised to the third power is equal to 10. It's really 10 to the first, right? Now what? Well, the goal is to find n. And I have this little clue that I haven't used. So why not substitute in? I mean, that's what we do a lot in math too, right? We factor out the GCF and we substitute things. And so I'm going to replace little b with 10 raised to the 1 over n raised to the third power is equal to 10. Okay, so this all Algebra 2 students, pre-calc and calculus students have had. When you raise a power to a power, you multiply the exponents. Actually, Algebra 1 and geometry students do this too. and that's equal to 10 to the first. My bases are now the same, and now I can set the exponents equal to each other, cross multiply, and I get n is 3. And that's the final answer. Yay! Okay. And this is the last one I'll do unless you would like me to do others. So I'm going to do this as the last problem, especially being a stat teacher. The mean and median is something I should really do. I want to compute the sum of all real numbers x such that the mean and the median of the following 5 numbers are equal. So where do I begin? Well, I know the median is the middle number when the data is when the data is sorted from least to greatest. And so if there are the 5 numbers, it's what's going to be wherever the third position. But we have this x that can be any value. So I'm going to start by saying, well, let me figure out the mean. What would the mean look like? Well, the mean is the sum of all the values of an expression, of all the data values, divided by 5. So the mean can be represented, if I add these up, that adds to 76 plus whatever x is divided by 5. What else do I know? Well, I know that the median has to be somewhere between 16 and 21 when the data is sorted. So the smallest value it can be is 16, less than or equal to. And the largest value it could be is 21, right? So now what? Well, that like 5 in the denominator is like an irritation. So I'm going to multiply this by 5. I'm going to multiply this by 5 and this by 5. I think you do this in Algebra 1, come to think of it. And this by 5. It's like one of those skills that I graded on the regions. So this reduces to 1, and I get 80 is less than or equal to 76 plus x is less than or equal to 105. I'm now going to subtract 76 from the ends of my interval, and I get that the lowest value x can be is 4, and the highest value that x could be is 105 minus 76 is 29. So I know x has to be values from 4 and 29. Okay. Now, that's a lot of values to go through. Remember, our goal is to find a value where the median and the mean has to be the same. And at this point, I'm going to use the calculator. And remember, I know 4 of the items. I also know that the values of x have to be, the value of x has to be an integer. That means the median has to be an integer. Okay, so I'm going to go into my calculator, and I'm actually, hold on. What I'm going to do is in the calculator, I'm going to type in the expression 76 plus x divided by 5, because that's my mean value, and that will quickly tell me what my mean is and allow me to compare to different medians. Hopefully when I do this, it will make more sense, because right now I know it may not make sense until I do it. So I'm setting up a new graph page in my calculator. Remember, you can use a calculator on this particular competition. And I'm going to hit Control Division. And I can type in 76 plus x, and I'm going to divide it by 5. I'm then going to go Control T, and I'm going to look for at x values between 4 and 29. Now remember, my mean has to be an integer value. So I'm going to look at 4 and 16 as one, I'm going to continue on. So 4 and 16 is one to look at. I'm going to look at 14 and 18. I'm going to look at 19 and 19. And I'm going to look at 24 and 20. And the last one is 29 and 21. So those are a lot less than 4 to 29. So it says save time. Okay. So I'm just gonna, so I don't have to spend countless hours doing this, what I'm gonna do is I had done the problem earlier and I'm just gonna list this out so hopefully you'll understand. All right, so if X was 4, because that one was the first one we saw, then I would order the data. Remember, X is 4, 4, 13, 16, 21, and 26. So my median is 16. And again, if you looked at the calculator and I scroll back up to 4, this is a little bit of a pain in the neck. I'm sorry if it's taking a long time. We see that it's 16. The mean is 16, yeah? So that's one solution. So 4 is one possible answer. I'm going to write that possible or answers. So that's a possible answer. Okay, so that worked. The next one was 9. So now I'm 9, just ordering it. And at 9, my mean at 9 was 17. So that didn't work. Okay. And the next one was 14. So I'm ordering it 4, 16, 21, 26. I lost a number. So 13, I lost my 13. And when I look at the median, which is obviously higher, so I guess I could have ignored it. It was 18, the mean. So that didn't work. Okay, the next one was, I think it was 24. I lost track. I didn't read my handwriting. Sorry. Let me just go down. It was 19. So 19. So it would be 13, 16, 19, 21, and 26, right? So now X is 19. And the median is 19, right? That's right in the middle. And if we look at our calculator, our mean was also 19. So that works. So far we have 419. And then we have, I believe, one more to go through, right? We scroll down. 29 and 21. So let's do 29. Well, 29 is the highest value. So I'm just going 13, 16, 21, 26, and 29. The median is 21, right? And when I look, guess what? That was also 21. So that worked. So that was also a solution. And they ask you to compute the sum of them because you only have one answer. And when you add that together, you add 23 and 21 is 44. And I didn't add that right. I'm sorry. This is not correct. Yes, the mean is 21, but the number that I added was 29. So I almost made a stupid mistake. Sorry about that, but I caught it. So 4 and 19 is 23, 23 and 29 is 52, and that's the answer to this problem. Well, I hope that this was helpful. This is great to prepare your mind for schools like MIT and Columbia. So if you're interested in going to these schools, please continue coming and continue learning. Have a great day.